Okay, now we want to talk about groundwater chemistry. And so let's go back to when we were talking about rivers. What were the three things that a river could carry in its channel? Okay, one was dissolved materials, one was sediment, like clay and silt that were in suspension, and then one was things like pebbles and rocks, which tended to either bounce or roll along the bottom of the river channel. So which of those three things do you think that you could have in groundwater? Well, you could have things that are dissolved in the groundwater. You could also have clay and silt in your groundwater, but you're not going to have too much rocks or pebbles because those kinds of things, they just can't fit through the cracks and crevices underground. But the other two things you can have. Now we're going to concentrate mainly on the stuff that is dissolved. So what are some materials that could be dissolved in groundwater? Well, one is you could have metals. So ions of iron and magnesium and copper and lead. And where did these things come from? So if you recall, igneous rocks tend to have metals in them, and so do some of the metamorphic rocks. So those kinds of ions will come out of those rocks and then they get into the groundwater. Okay, another thing is going to be silica. So if you recall, we said that most of the rocks on Earth are silicate minerals, or have the silicate minerals in them. And so a silicate mineral has silica in it. So as those rocks that have the silicate minerals dissolve, what can happen is the silica can go into solution. Then the final thing that could be dissolved in groundwater is going to be carbonates. So if you recall, we talked about limestone, and limestone had in it the mineral calcite. And calcite was going to be calcium carbonate. Okay, so what is going to happen to this calcite that is in limestone as groundwater percolates through it? Okay, so the first thing that's going to happen is that water, it could be water in rain, or it could be water in the soil, is going to mix with carbon dioxide, the stuff that you breathe out. And so that could happen. The carbon dioxide could be floating around in the air, and then it combines with rainwater to make carbonic acid. And so carbonic acid is going to be H2CO3. Now you'll notice that there is a double arrow. So there's an arrow that's pointing this way, and then there's an arrow that's pointing in the opposite direction. And so that means that under certain circumstances, carbonic acid can change back into carbon dioxide and water. So it all depends on the pH of the environment that it's in, which form that it wants to be in. Okay, now this is an acid. And one of the things that a lot of acids, the characteristics that they have, is they give off hydrogen. So one thing that could happen is you have this H2CO3, and then it's going to give off a hydrogen ion, and then what's left over is going to be called bicarbonate. So that's going to be H, and then it's going to have CO3 in it, and it's going to be a negative sign. So this is an ion, and then this is an ion. They're still all dissolved in the water. So this is stuff that's flowing around in the water. Then this hydrogen can also come off as well. But one of the things, what's going to happen to this hydrogen, though, is it's going to attack the calcium carbonate. And so the hydrogen's going to come in, and it's going to disrupt this bond, that's holding that calcium onto that carbonate thing. So that what you're going to end up with is more hydrogen carbonate, more of this bicarbonate thing, which combines with this bicarbonate thing, so that you end up with two bicarbonate things. And the calcium. So this calcium comes off the calcium carbonate and it goes into the groundwater. Now, what can happen is later the calcium can recombine with the carbonate to make more. Now, we're not going to call it calcite. We're going to call it travertine. So when it goes back together, it's going to make a mineral that is very similar to calcite, but the mineral is going to be called travertine. And again, notice that the arrows, they go in both ways. So this is going to be very important with cave formation, that under certain circumstances, acid is going to be in the groundwater. It's going to eat away at the calcite and dissolve it and carry it away, and it's going to leave a hole. And what are we going to call that hole? A cave. Then later, what can happen is groundwater can percolate back into the cave, and it can redeposit calcium carbonate in the form of travertine, and then that is going to be stalactites and stalagmites. So we'll see that in a future segment here. All right, so let's take a break, and when we come back, let's talk about the landforms that are going to be created by groundwater.